Hi, I thought I'd tape a video today on discriminants. Now, before we get started, discriminants are part of the quadratic formula or the quadratic equation, and that looks like this. When I'm trying to find a root, a zero, or where my graph is going to cross the x-axis, I have this formula that I can use. It's negative b plus or minus b squared minus 4ac divided by 2a. And this is for a quadratic in the form of ax squared plus bx plus c is equal to 0. And one of these terms can be 0, and that would mean that, or one of these variables could be 0, a, b, or c, and so then it would just kind of eliminate the term. So if I saw something that looked like ax squared plus bx is equal to 0, I'd be fine. If I saw something like ax squared plus c is equal to 0, I'd also be fine. So when I'm talking about the discriminant, I'm talking about the b squared minus 4ac underneath the radical. And what this tells me is basically if the graph is going to hit the x-axis. So, and I know that doesn't mean much to us right now, but it will later on. So I'm dealing with parabolas, so my parabolas can look something like this. And this is a type of parabola that hits the x-axis twice. So there's two real roots, or two real answers. I'm going to get x is equal to a half, or x is equal to negative 4. But I'm going to get two actual numbers whenever I either I factor or I use the quadratic equation to solve my quadratic. So this is two real roots, and this is when the discriminant is positive. So whenever I say b squared minus 4ac, if that equals a positive number, there are two real roots, or two real answers. And then I have a situation sometimes where my graph is going to end up looking something like this, where it never ever crosses the x-axis. And in this case, I'm going to end up with two imaginary roots. And I'm going to give you an example of this, and I know you've seen it before because we've done some problems in class where you've ended up with, when you solved for x is equal to 2 plus or minus I radical 2. This would be an imaginary root. Like I would have a 2 plus I radical 2 and a 2 minus I radical 2. And so the graph may look something like this. It's never going to cross the x-axis. No matter what value of x you give me, it'll never cross over the x-axis. So in this case, this is where underneath the radical is a negative. So the discriminant b squared minus 4ac, it's going to end up being a negative number whenever I plug in my values. And then there's one more type of situation, and this type of situation is where there is only one answer. And that means it only hits the graph one time, or hits the x-axis one time. So this is one real root. And this is where x is equal to, it could be like x is equal to 3 halves. That would be one real root. So this is when my discriminant, b squared minus 4ac, is equal to 0. So you ask, what are some examples? And you can see on page 31 in your packet, we can look at a couple of different problems. So my number 11 on page 31 is this, 8x squared minus 9x is equal to 0. And in this situation, this is a situation where a is equal to 8, b is equal to negative 9, and c is equal to 0, because there's no c term. So I know c is equal to 0. So I plug it in. For b squared would be negative 9 squared minus 4 times a times c. And in this case, it's going to be 81 is going to be my answer. So it's going to be, my answer is positive. There are two real solutions or real roots. That's how you would answer that. 81, it's positive, two real roots. If I look at number 12, I have a squared minus 3a plus 2 is equal to 0. A is equal to 1, b is equal to negative 3, and c is equal to 2. I do negative 3 squared minus 4 times 1 times 2. So I have 9 minus 8 is 1. 1 is positive. 2 real roots. Now we are going to run into situations where it's going to be negative, and so hopefully we will soon. Number 13, we have 5v squared minus 2v plus 4 is equal to 0. A is equal to 5, B is equal to negative 2, and C is equal to positive 4. So I do negative 2 squared minus 4 times 5 times 4. And so I have negative 2 squared is 4 minus, and I have 4 times 5 is 20 minus 80. And so that answer is going to be negative 76. And so that is negative. So looking at my discriminant is a negative number. I have 2 imaginary roots. So hopefully that'll help you with the discriminant.